that the only one that can separate sugar from a mixture is crystallization, because it is the crystallization that is used in what? Sugar production. So there is no other answer other than crystallization. So you go to your option and pick crystallization. That's answer the question number 1. Question number 2. The order in which mixture of sand, ammonium chloride, and sodium chloride can be separated is: you have sand, you have ammonium chloride, then you have sodium chloride. If you look at this very well, you will need to employ more than one separative techniques. So if you have this, look at this ammonium chloride. If you want to remove ammonium chloride, because it is a substance that sublimes, that is moved from solid to gas without passing through the liquid state. So ammonium sublime. So if you want to separate ammonium from this mixture, all you just need to do is to subject the mixture to what? Sublimation. So when you subject this mixture to sublimation, ammonium will be gone. So ammonium chloride will be gone. Then you'll be left with what? Sand and sodium. Then the next thing you need to do is to dissolution. That's what they call dissolution. That is, you introduce water. Dissolution. This one is an insoluble substance. This one is soluble in water. So when you dissolve these two mixtures in water, then you now pass it to what? This one is insoluble. This one is soluble. Then you pass it through a process known as what? Filtration. So filtration will remove sand, because the sand will be on the filter paper, and this one goes into the solution as what? A filtrate. So you can see now that if now I want to and this one that goes into the filtrate, so how many processes have you employed now? You have sublimation, then you have a dissolution, then you have filtration. It now depends on what the question is really testing. So if the question is testing, so what you have left is what? Sodium chloride solution. So if you now want a sodium chloride solid as in form of solid, then you can now pass this process to what? Evaporation, to remove the water. Then you have it as what? Solid. But if the question is only interested in sodium chloride solution, then you stop here. So you have sublimation, dissolution, and filtration. But if sometimes the question requires you to find or to show how sodium chloride solid is separated, then you still now say evaporation included. So if it is just sodium chloride solution, you have sublimation to the solution and filtration. But if it is sodium chloride solid, you have sublimation, dissolution, filtration, and evaporation. So take note of that. That was also another JAMB or UTME question. A mixture of petrol and water can be separated through mixture of petrol and water. How do you separate a mixture of petrol and water? The first thing you ask yourself, that if you look at this very well, you discover that this one is definitely an organic compound, while this one is an inorganic compound. This one is a polar compound, is polar, and this one is what? Non-polar. So here you know that if you are to separate these two, this one is definitely less, this one is less dense than water. So which separative techniques employ density? There is no other one other than what? Using separating funnel. Because when I explain separating funnel, I use kerosene and water, but here they use petrol and water. So it is separating funnel that you are going to use. Why this one remain on it? It will remain on it, on the solution, while this one goes in, because this one is denser than this. So the process to separate petrol from water is by using separating funnel. Take note of that. So the next question asks us that chlorophyll obtained from green leaves of plants is shown to be composed of more than one colored compound by the technique of I explained this earlier. So I said they said chlorophyll from leaves. So and I said whenever you come across any one of these guys, colors, proteins, ink, leaves, it it is no other process than what? Chromatography. So the answer to that very question is chromatography. Then they ask again, a mixture of sugar and sulfur can be separated by, this is a repeated question, it's a repetition, because we talk about sugar is separated from its mixture earlier. So automatically, when you have sugar and sulfur, how can you separate sugar and sulfur? How do you separate sugar and sulfur? It's mixture with sulfur. Automatically, it's by crystallization. So by the time you subject this to crystallization, this will come out in form of crystal. And that is how to separate sugar from its mixture. Then another question here says that in countries where the temperature falls below 273 Kelvin, salt is always sprinkled on the icy roads in order to, why you sprinkle salt on the icy road is to lower the melting point. Because you know that when you sprinkle salt, I said initially that impurities lowers what? The melting point. Why? It increases the boiling point. So when you have salt sprinkled on the icy road, is due to the fact that they want the what? The melting point to be lowered. So that is the significance. It is in order to lower the melting point. Question number 7. Which of the following is a physical change? A. Freezing ice cream. B. Dissolving calcium in water. C. Burning of kerosene. D. Exposing white phosphorus in air. The first one says that freezing of ice cream. So when you talk about freezing, when you freeze something, that means you have a liquid to what? Solid. That's solidification. So you are trying to convert a solid to what? You are trying to convert a liquid to what? A solid. That is the process of freezing. So how do you convert? This one is definitely going to be a reversible reaction. So how do you convert? This is freezing. You are freezing the ice cream. So when you freeze it, it becomes solid. So how do you want to convert solid to liquid? By what? Melting. So when you melt this, you convert it. So you can see that option number 1 is definitely a physical change. So the answer to that question, every other one will definitely be what? A chemical change. Burning of kerosene, you can't reverse it. Exposing white phosphorus in air, you can't reverse it. Also, dissolving calcium in water, you can't reverse it. So automatically the answer that will be suitable for that question number 7 is A. That is freezing of ice cream. Then question number 8. Which of the following is an example of a mixture? You have sand, washing soda, common salt, and Coca-Cola. Sand. What is the formula of sand? That's the molecular formula SiO2. You can see that now. A mixture can never be represented by what? A chemical formula. Remember. So that means since I can represent the sand with this is silicon dioxide. So you can represent sand with a chemical formula. So this one can never be the answer. Then the second one talks about washing. Washing soda. What is the formula of washing soda? Washing soda is sodium carbonate decahydrate. This is washing soda. It's even a fluorescent substance. So you can see that I can still represent washing soda with what? A molecular formula. So this one can never be the answer because a mixture can never be represented by a chemical formula. Then the next one is common salt. Common salt. What is the formula of common salt? Common salt is sodium chloride. So a mixture can never be represented with a molecular formula. Then the last one is Coca-Cola. Yes, Coca-Cola. Coca-Cola does not have a molecular formula because in Coca-Cola you have cola, you have water, you have carbon dioxide, you have etc. So how do you represent this by a chemical formula? It is impossible. So definitely Coca-Cola is the answer. That's option D. Question number 8. The principle of column chromatography is based on the ability of the constituent to A. react with each other in the column. B, move at different speed in the column. C, dissolve in each other in the column. D, react with the solvent in the column. So if you look at it, in a column chromatography, the basis of separation, I've said it, is as a result of what? Affinity the substance have for the what? Solvent. Affinity of the substance for the solvent. So in your column chromatograph that is packed with beads, you see packed with beads. So in that column, say you have your solvent somewhere around here. So you have your solvent somewhere around here. Let's say this is where you have your solvent. So it is packed with beads all around. So the ability of the solvents here to move is so the column chromatography separates on the basis of what? The speed down the what? Column. So you go to your options and look for where you have the speed. The speed down the column. So B says that move at different speed in the column. So that is definitely the answer to the question number 8. Question number 9. Which of the following methods can be used to obtain pure water from a mixture of sand, water, and methanoic acid? So you have pure water from a mixture of sand, water, and methanoic acid.